Welcome to Unit 3, Lesson 5 on sources of energy. By the end of this lesson, you should be able to demonstrate an understanding of the various sources of energy, and you'll know you've been successful when you are able to describe the various sources of energy, investigate how to use different types of energy, and apply your learning to daily life problems. We're going to start by watching a brief video on the different sources of energy.
Sources of energy. What is energy? Energy is everywhere in nature. That is, energy is present in sunlight, wind, water, plants, and in animals. We need energy to do all activities. Energy does things for us. Thus, energy can be defined as the ability to do work. Good source of energy. A good source of energy would be the one which would do a large amount of work per unit volume or mass, be easily accessible, be easy to store and transport, and be economical. Fossil fuel. Fossil fuel is a hydrocarbon deposit such as petroleum, coal, or natural gas, derived from living matter of a previous geologic time and used for fuel. What is a power plant? A power station or a power plant is a facility for the generation of electric power. Thermal power plant. A thermal power plant utilizes thermal energy of fuels such as coal, oil, natural gas, or radioactive substances for the generation of electric power. Energy transformation in a thermal power plant. In a thermal power plant, the chemical energy stored in fossil fuels or radioactive substances is converted successively into thermal energy, mechanical energy, and finally to electrical energy. Hydropower plant. In a hydropower plant, electricity is produced from water. Hydropower plants convert the potential energy of water into electricity. Wind energy. The sun causes uneven heating of the Earth's surface. Air over land heats up faster than the air over water. Warm air rises up and cool air rushes in, causing movement of air. Moving air is called wind. Wind possesses kinetic energy. Uses of wind energy. Wind energy can be used to sail boats, grind grains, pump water, and generate electricity. Solar energy. The sun has produced energy for billions of years. Solar energy is the solar radiation that reaches the Earth. Solar energy can be converted directly or indirectly into other forms of energy, such as heat and electricity. Uses of solar energy. Solar energy is used for heating water for domestic use, space heating of buildings, heating swimming pools, drying agricultural products, and for generating electrical energy. Major drawbacks of solar energy. The major drawbacks of solar energy are: it arrives the Earth's surface intermittently and in a variable manner. It has to be concentrated using parabolic mirrors. Biomass. Biomass is an organic material obtained from plants and animals. Some examples of biomass fuels are wood, crops, manure, and some garbage. Biomass contains stored energy from the sun. Plants absorb the sun's energy in a process called photosynthesis. The chemical energy in plants gets passed on to animals and people that eat them. Biomass is a renewable energy source because we can always grow more trees and crops. Biomass can be converted to other usable forms of energy like methane gas or transportation fuels like ethanol and biodiesel. Solar cell. A solar cell is a device that converts solar energy into electricity. A typical solar cell develops a voltage of 0.5 to 1 volts and can produce about 0.7 watt of electricity when exposed to the sun. A solar cell panel is an assembly of solar cells used to generate electricity. Uses of solar cells. Solar cells or solar cell panels are used in artificial satellites and in space probes like Mars orbiters, wireless transmission systems or TV relay stations in remote locations, traffic signals, calculators, and in toys. Energy from the sea. The sea has long been seen as a source of energy. There are 3 basic ways to tap the ocean for its energy. We can use the energy of the waves, we can use the ocean's high and low tides, or we can use temperature differences in the water. Tidal energy. Tidal energy, sometimes called tidal power, is the power wave energy, the huge moving waves, ocean thermal energy. The energy of geothermal energy. Energy obtained by tapping underground reservoirs of heat, usually near volcanoes or other hot spots on the surface of the earth, is known as geothermal energy. Nuclear reactions. Nuclear reactions are those reactions wherein a nucleus, when bombarded with nucleons or other subatomic particles, undergoes a change in its composition. Types of nuclear reactions. Nuclear reactions are broadly classified as nuclear fission reaction and nuclear fusion reaction. Nuclear fission reaction. The process of splitting of a heavy nucleus into a number of light nuclei with the liberation of tremendous amount of energy and 2 or 3 neutrons is called nuclear fission. Nuclear fusion reaction. Nuclear fusion is a reaction in which 2 or more light nuclei combine to form a heavier nucleus, releasing an enormous amount of energy. Nuclear fusion is the type of reaction taking place inside the sun. Inside the core of the sun, fast-moving hydrogen nuclei combine to form helium nucleus. Nuclear fusion takes place at a very high temperature of the order of 10 to the power 7 Kelvin. Hence, nuclear fusion reaction is called thermonuclear reaction. Nuclear fusion is the basic principle of the hydrogen bomb. What is a nuclear reactor? A nuclear reactor is a device or a furnace where controlled fission chain reaction is carried out and the energy released is used to generate electricity.
And now we are going to watch a video on renewable and non-renewable energy sources.
Renewable energy, pronounced renewable energy. It's any natural resource that can replace itself quickly and dependably. It's an energy source that can never, ever be used up. It can also be called by its synonyms, alternative energy or green energy. But what we really want to know is which resources are renewable and why. Solar power converts sunlight into electricity. The sun has been emitting light energy for billions of years, and it will continue to naturally replenish that energy for an estimated 7 billion years. For this reason, solar is considered a renewable energy source. Geysers result from water being superheated by magma at the Earth's core. The Earth's core constantly produces thermal heat energy. Whatever thermal energy we transform into electricity won't put a dent in the core's temperature. That heat is continually replaced. This is why geothermal power is derived from a renewable energy source. Wind power turns motion energy into electricity. Windy areas make for great windmill farms where motion energy is harvested from a continuous breeze. Next time you see a windmill, look a little closer to see a naturally replenishing renewable energy resource. Fossil fuels. Fuels that were formed deep within the earth from plant and animal remains that are millions of years old. This material can be burned once and only once for energy. You may also know it by its synonyms, non-renewable resources or unsustainable energy. The three major fossil fuels we use as energy sources are coal, natural gas, and oil. So I ask you, are fossil fuels renewable or non-renewable energy sources? Well, let's find out. Fuels made from fossils, like coal, are limited. Once it's mined and burned for energy, it's gone. Unless the dinosaur age happens again, coal will not be replaced, so it's non-renewable. Natural gas and oil, also fossil fuels, are non-renewable. There's only limited amounts of fossil fuels. Once they are pulled from the earth and burned for energy, they're gone. That's why they are non-renewable energy sources. All right, time to review. Energy harvested from wind is replaced quickly and naturally. Is this a renewable resource?
You betcha.
This pump extracts oil, a fossil fuel that's burned for energy and cannot be replaced. Is it a renewable resource?
No way.
Look at this energy resource group. Is it renewable?
Why, yes. Yes, it is.
What about this group? Is it renewable?
Not even close. I think I'm done here.
So to review, a non-renewable energy resource is an energy-rich substance that cannot be replenished as it is used in energy transforming processes. Fuels such as coal, oil, and natural gas are common non-renewable energy resources. A renewable energy resource is an energy-rich substance with an unlimited supply, or a supply that can be replenished as the substance is used in energy transforming processes. Radiant energy from the sun is an example of a renewable energy resource. Solar energy is radiant energy from the sun. So we have passive solar design, building design that uses the energy's radiant energy directly for heating. So we can get these through orienting buildings so that they have one wall facing the sun, placing more windows or larger windows on the sunny side of the building so the light and heat can be absorbed inside, placing tall deciduous trees on the sunny side of a building so the sun's rays are blocked in the summer when the trees are covered in leaves, but not in the winter when the leaves have fallen off the leaves. So we can use the environment to help shade the house and provide cooling in the summer, but still allowing the sunlight through in the winter when we need the heat from the sun, especially if we live in a place that gets snow. Solar energy is a renewable form of energy. A lot of times people will use solar panels on their roofs so that the panels absorb the sunlight and convert it into electrical energy, which allow the house to be powered, or the building to be powered, using electricity from the sun instead of electricity from our power grids, which are created using fossil fuels or hydroelectricity using water and things that are not necessarily sustainable. Photovoltaic cells, we're going to watch a video on this.
Here's another great video brought to you by Brayton Energy Canada. For more information, please visit www.energyconsultingadvice.com. Thanks for watching and enjoy the video.
The solar panel uses photons from the sun to create electricity. Let's take a closer look at this nanoscopic process, which enables us to harness electricity from the sun. The top and bottom layers are protective glass with conducting coatings. Electricity in the form of electrons flows in and out of these conductive coatings while the electrical production process happens in the middle layers. To understand what goes on in these middle layers, we need to zoom in to the molecular level. A photon strikes a dye molecule absorbed on the surface of the TiO2, causing an excited state which releases an electron into the TiO2 that exits through the conductive layer. The electron does its work and returns to the cell via the bottom conductive layer. With the help of a catalyst layer, the electron enters the electrolyte and interacts with a triiodide molecule. Along with another electron, this reduces it to an iodide ion. The iodide ion makes its way towards the activated dye molecule and transfers an electron to the dye. The iodide ion reforms back to triiodide, and the dye molecule reverts back to its previous unactivated state. The dye is now ready for the next photon from the sun. This process occurs billions of times per second inside the cell to create an electrical current from sunlight.
We have reached the end of our lesson, so be sure to complete the quiz below. And as always, if you have any questions, please be sure to contact your teacher.